It's biology with Mr. B. Biology with Mr. B. That's me! Heyo, year 11. Right, I am continuing from the last video. So, in terms of you doing this lesson on Thursday, I generally don't know how much of this you'll get time to do. If the cover teacher can let me know, that'd be fantastic. So, what I hope to achieve today, number one, I had a couple people emailing me, and thank you. Thank you to those who generally emailed me being unsure. So, I want to make sure every single person is clear on what the homework is. That is due next Thursday in our double period, including where to find resources on Teams. Because I've not just asked you to complete some questions, I've asked you to mark them and fill in like a what went well, even better if on the front with your scores. Do excuse me, I'm just plugging in a little device. Oh, and I just broke it. There we go. So, a reminder, the homework due next Thursday. Where is it? Homework due next Thursday. That would be 27th. It's to complete and mark the 2 booklets you were given last week. That was cell structure and transporting cells. It's nice to see that my handwriting is looking sharp today. That is disastrous. Okay, so complete and mark 2 booklets, cell structure and transporting cells. If you didn't get those booklets, can you make sure you just go and ask today, yeah? Ask and go get them from Jill from the prep room. She'll just pass you one, won't she? Or if we haven't got a spare, she'll probably print one for you, wouldn't she? And even if you've not, well, I'm going to show you where they are, so you can just access them digitally instead. So, being a noob, I've gone straight into this without any planning, and I've not even opened up Teams. I don't actually have the Teams app on my on this laptop, so I'm going to go in Teams Loing. I don't know what a Team Loing is. I'm going to go in the long way, but it's one of those. We don't need the app in order to access Teams. I do prefer the app on the phone, but on the laptop, not real big difference for me. So I've gone in straight away because I was already signed in. So either way, I'm going into Teams. I'm a member of loads of teams. You're probably a member of loads of teams as well. But we are all of us, we are all members of GCSE Biology Resources. If you go into the File section and click on Class Materials, everything's got to be in the class materials because that makes it secure and uneditable. If you don't put it in there, then people can just edit it and it's disastrous. So, I have a huge amount of information to help students. This generally is not for me. This is all revision stuff, helpful stuff for students. So, for example, I've got a massive bank of what type of 6 markers could they ask? I just wrote them all out and I answered them. And I popped in a PowerPoint, put it there. For specific information on some of the required practicals, like helpful tips and things, I've been popping them in there. So some of these things are still building, but what is really detailed is what you find in paper 1 and paper 2. The 2 topics I've set for homework are in paper 1. So you click on that, there's cell structure, there's transporting cells. Take cell structure as an example. If I click on that, if you haven't got the booklet to look at the spec points, it's in there. You probably won't find that much helpful things in teaching resources. Effectively, if we've got a PowerPoint that's quite notey, we've put it in there, but we tend not to use very, very super notey PowerPoints. Well, certainly I tend not to. Topic-based questions. This is your homework. Obviously, you guys click on Year 11. If you do want some extra questions, I don't think you'll have time to, but if you do, there are some extra ones in the Year 9 and 10 bit. I've made sure the best ones are in the Year 11. So they are the questions that you've been set, and that is the mark scheme. So when you have completed the questions, get your green pen, open the mark scheme, mark it to the best of your ability, ask questions, send me a quick message on Teams or a quick email, or have I done this correct? Send me a picture and I'll let you know. Please be really proactive. And boom, you're done. Avoid your stress. Revision material column is also really good. This is every single topic in GCSE has this. This is a revision booklet made by me because still revision guides are not suitable for students of your ability. There's a lot of you in the room who are legitimately going for grade 7s in the biology components of your combined science course. And most of the revision guides, even the ones that are labelled like 9 to 7, they aren't great from an examiner's point of view. So I made my own with my versions of the notes, with where possible I've done like worked examples of some of the skills. So in this case, it's obviously the worked example of how to calculate magnification. Yeah, I've made that for you. Please use it. Super proactive people would probably print those, wouldn't they, and keep it alongside. But well, those were the old days. Each topic also has a video. You can either access it and download it there, or you can go to YouTube and Biology with Mr. B, and you can find them there. Feel free to like and subscribe. Well, I'm going to push that at you. But that's where they are. If anyone wants the teacher to now just rewind that so you can show exactly where on Teams you find that mark scheme and that work, obviously let them know now. Right, my job then. Let's keep going with this. Let's make a new slide. I want to recap the reflex arc that was taught last lesson, and I want to see if we can add a little bit to it. So last lesson. Okay, let's see if I can actually write semi-neatly. Last lesson, we looked at developing a story, really, called the reflex arc. And the reflex arc, if I do it simply, it began with a stimulus. A stimulus being a change in the environment, like light, sound, a chemical for like smell and taste. Like could be pressure on your skin or temperature on the skin. Some sort of change in the environment. And that change was always detected by a receptor. And that receptor is a cell found in a sense organ. So a cell in the eye is a light receptor cell for the stimulus of light. In your ears, you have sound receptor cells for the stimulus of sound, and so on. Once the receptor detected the stimulus, that's the worst arrow in the world, I'm sorry guys, detected the stimulus, an electrical impulse was generated. And an electrical impulse, not message, impulse, was generated. And that electrical impulse was transmitted to your central nervous system, which was the brain or the spinal cord. An electrical impulse was then fired from the brain and spinal cord. I've got the wrong colour pen there. To the effector. I'm just going to write in again that this is an electrical impulse. Not a message, not a signal, an impulse. And this effector is going to cause a response. So to be an effector and cause a response in your body, a response that is effectively a response to the original stimulus, you're either a muscle or you're a gland. Muscles will enable your body to move, so like moving your hand away from something hot, or moving like a muscle in the arm to protect your face, moving muscles in your bladder to expel urine when you get scared, Lucas, whatever it needs to be. Could be a gland. I gave the interesting example of like, if you see cake, you might start salivating because you're feeling hungry. But again, the stimulus was light coming from the cake, the light reflecting off the cake. Your brain has gone, "Ooh, cake, hungry." And the response was to start salivating, releasing saliva from glands, so that you are ready to digest that cake. And obviously your stomach would be secreting protease enzymes at the same time. The last thing we did in this, because that's our reflex arc, but the last thing we did was try to add the names of different neurons. The neurons, the nerve cells that actually transmit the electrical impulses. From the receptor to the central nervous system, it was called a sensory neuron. From the central nervous system to the effector, it was a motor neuron. And in the middle, between the sensory and motor neurons within the central nervous system, there were also little tiny relay neurons connecting the two. So far, there's a lot of information there. That's a big fat 6 marker if you try to actually say that all in one go. That's our reflex arc. That's probably the key idea from this topic. The one that we're going to be quite repetitive going over. What I want to talk to you about today is what happens when two of these neurons meet. What happens when you get two neurons together? And I'm going to apologise for the shape now, but I assure you that generally is their shape. If you need to pause this to subside the laughter from some immature people, feel free. Right, so when you're ready, there's a couple of places you could do this. This is you, students. A couple of places you could do this. Either I want you to do this in your books, or if you look at task 6 in the booklet, I may as well show it. If you look at task 6 in the booklet, there is actually a space which already has a drawing of something similar that I'm going to draw. And we're going to annotate and label it. So either you prefer to do it on task 6, or, I mean, I'm looking at that and I'm thinking the photocopying is a bit rubbish. So hence why I don't want to label that. I want to draw my own. But I'll leave it completely up to you which one you choose. If you are doing it in your book, you absolutely will want a little title. That title is the synapse. And the synapse, and again, if you're doing this on task 6, you still need to write this definition down, please. The synapse is the gap between two. That's not how you spell two. Oh dear. The gap between two neurons, two nerve cells. And I'm going to try my best to draw it. Best of my ability here, generally. I'll have one neuron coming this way, and at the end of the neuron it does sort of go a bit rounder, increases its surface area. And I've got another neuron here. I don't know why I've done it as a circle. It needs to get, that's not what I wanted to do either. Never mind. Let's see if I can do it correctly this time. That's good enough. And I have another neuron there. Right. The first thing to bear in mind is the synapse is literally that gap there. If I say the word synapse, I mean the gap. Oh. One day this will work as I expect it to. So there, that is the synapse. That's the gap in the middle. And let's pretend that this is a sensory neuron up here. So this neuron, which is on the left-hand side, is a sensory neuron. And sensory neurons should always connect to a relay neuron. So this one here is a relay neuron in the CNS, in the central nervous system. So spinal cord or brain. So we're actually going to use a bit of physics. I know, physics. We know that there is an electrical impulse travelling along this first sensory neuron because the receptor cell detected the stimulus and it triggered this electrical impulse. And the electrical impulse will travel all the way along this lovely insulated nerve and it'll get to the end. From your knowledge of wires in physics, can electricity jump between wires? No. Because air is an insulator. That's why if you have like a short circuit in a light bulb, it doesn't just jump out at you when you're sat on the ground because it can't get through the air. If you touch the light bulb, you're buggered, but as long as you don't touch it, it's not going to jump out at you because the air is an insulator. And we've got exactly the same effect. The electrical impulse can't jump the gap. But I still need something to happen to trigger a new electrical impulse in this relay neuron. Otherwise, no impulse would get to my effector and my body wouldn't respond to stimuli. I mean, this could be a really important bit of information from a temperature receptor telling you that you've just put your hand on a hot barbecue or something, I don't know. So if that information doesn't get to your effectors telling you to pull your hand back, that could cause serious injury. But the electrical impulse, and that's what I'm doing in green, electrical impulse, cannot jump the gap. So here's what happens instead. Inside this end part of the neuron, and cue laughter, it does have a name. It's called the Synaptic Knob. That's K-N-O-B. Yep, you heard, Synaptic Knob. Anyway, inside this end part of the neuron, the bit that's next to the synapse, there are little vesicles, like little vacuoles, think of them like that. And inside, they will contain a little chemical, which we know we call a chemical transmitter. So I'm just going to do that up here. These little dots that I'm doing in red equal chemical transmitters. When the electrical impulse arrives, these little vesicles filled with the chemical transmitters are told to move to the membrane. And what they'll do, by moving and fusing with the membrane on this side of the synapse, they actually are able to release the chemical transmitters into the synapse. On the other side, so in this case the relay neuron, it will have little receptors on its membrane that are specific in shape to these chemical transmitters, so the chemical transmitters can actually bind to them. So I'm just going to draw some of these red one dots, literally joining, binding. And if enough bind, so if enough of these chemical transmitters bind to these receptors on the next neuron, it will trigger a brand new electrical impulse in the next neuron, in this case in the relay neuron. Now these chemicals, they got released, They then diffuse across the synapse from a high to a low concentration, bind to the receptors on the next neuron, and trigger this brand new electrical impulse. Let me summarize this with words. The first thing that happened was an electrical impulse reaches the synapse of the first neuron. In this case, that's a sensory neuron, but it could be a relay. The electrical impulse triggers the release of chemical transmitters into the synapse. The chemical transmitters diffuse across the synapse and bind to receptors on the next neuron. In my diagram, I've done it as relay neuron, but it could be a motor. It depends which are which. If enough bind, a new electrical impulse is generated in the second neuron. These chemical transmitters, guys, they don't stay in the synapse. The chemical transmitters will eventually get recycled. So let's see if I've got space to add that in. Chemical transmitters, CT. It won't let me do it. It's just, oh, how the monkey have I done that? How do I fix that? Oh, there you go. Chemical transmitters are... I'm trying. I promise I'm trying. Right here. Recycled. Oh, look! I've got words! I don't know how I'm going to fix this. That was new. No idea I did that. Chemical transmitters are recycled into the first neuron. So they just go back and they wait for a brand new electrical impulse. So that is the story of the synapse. What I'd recommend is that the cover teacher sort of pauses me, goes back to the beginning of this drawing, this explanation, so they can go through it one more time. I think that would be really, really helpful. It's one of these things, and it's another process that with repetition we do get really good at it. And I'd like you to have a go at the following task, please. Obviously, this completely depends if you've got time. I appreciate I may have set too much work to do over these two lessons. But the task I'd like you to do are task 9 and task 10. Task 9 is relatively nice enough. It's just sort of labelling different components of our reflex arc. Task 10 is what I would call the classic 6 marker. So reflex arcs come up a lot as 6 markers because I'm sure you can appreciate they are nice big processes. You should hopefully now that I've done about the synapse as well be able to describe the full pathway. The full pathway from seeing something by your eyes, so a stimulus, all the way to a response. If you can, see if you can include simple information about a synapse as well within that answer. It'll be tricky too, because the bulk of the answer doesn't need the synapse. But if you're really intelligent, you might be able to just put a sentence in or so to suggest its location. One last thing before I sort of let you just crack on with that. Ooh, messy. I will just want to clarify because I think I forgot to. We've been talking about the electrical impulse inside the nerves. We would actually call these chemicals diffusing a type of impulse, but we'd call it a chemical impulse. So we go electrical in the nerves, chemical across the gap, and then electrical again inside the new nerve. Right. Thanks for your time, everyone. Please bear in mind that 6 marker is one that I usually mark, so I should be back by next Thursday, surely. So presumably I am absolutely back and absolutely fine. I will be collecting task 10 in so I can mark it. So thanks so much for your time, guys. Bye.